Hi everybody! In this video, I'm going to be going through the notes for lesson 2.9. In this lesson, we are going to be learning about relationships between lines. So instead of looking at one line at a time, we're going to be looking at more than one line. And we are going to learn about what makes lines parallel or perpendicular to each other. Let's start with parallel lines. If lines are parallel, it means that they will never touch each other. Parallel lines have the same slope, but they have different starting points. When we talk about parallel lines, we use the symbol for the word parallel, which looks like two little mini parallel lines right next to each other. Let's look at a picture, a graph that shows us parallel lines. So in this graph, you'll notice we have two different lines here. The first line is this one, and the second line is this one. What we're going to notice is that they have different starting points. So the y-intercept of the pink line is +1, and the blue line is -2. But if we look at their slope, so if we find a couple more nice points and we count the slope number, the rise is 1 and the run is 2, which means the slope is 1/2 for the first line. And for the second line, the rise is also 1 and the run is also 2. So the slope is also 1/2 for the second line. These lines have the same slope, but they have different starting points. So these lines are parallel. We can also tell whether lines are parallel or not by looking at their equation. For example, in these equations, if we zoom in on just the slope number, remember the slope number is always the number that is right before the x or right before the parentheses. So in the first equation, the slope is 1/2. In the second equation, the slope is 1/2. And in the third equation, the slope is 1/2. If we were to graph these lines, they would all be parallel to each other. These are the types of problems I might give you where I ask you about parallel lines. In problem 1, I am asking you to graph a line that is parallel to the given line, but goes through this new given point. So my new line should go through this point, but it should be parallel to the other one. In order to do that, I need to steal and use the same slope as the line that I've already got. So I'm going to find a few nice points on this line. On this line, the rise is 2, and the run is 1. So my slope is 2/1. That means that for the next line that I draw, I should copy and paste that same slope. I'm going to go up 2/1, up 2/1, up 2/1. It is really important to draw specific points. Don't just eyeball it. Copy and paste the same slope, and then use your straight edge, like your ID or the edge of a piece of paper, to draw a nice straight line. Now, the second part of this question says, write the equation of the line that you drew. In order to do that, we're going to need to identify the key features. So we're going to need a point, and we're going to need a slope. We already know the slope because it should be the same as the slope for the other line. We also need a starting point. Now, the starting point in this problem was this point that I had to draw my line through, and that point has the coordinates -3, -2. Then we're going to put those together and we're going to make the equation. Y equals my y value, which is -2, plus my slope, which is 2/1, and then parentheses x, and then plus 3. Remember, this number is always the opposite of the one that you see in your point. Let's try this again. So in problem number 2, I'm asking you to graph a line that is parallel to the given line and goes through this new point that I gave you. Step number 1 is to figure out the slope of the line that we're trying to be parallel to. So the line on this paper has a few nice points. It looks like I'm going to be going down 2, right 3. So -2/3 is my slope. I'm going to copy and paste the same slope. So down 2, right 3. Down 2, right 3. And then I'm going to draw a nice straight line through those points using the edge of a piece of paper or my ID. Next, I'm going to write the equation of that line. Again, I'm going to need some key features, a point and a slope. We already know our slope should be -2/3 because it should be the same slope that the other line had. Then we're going to use this point that I gave you as a starting point as your point for your equation. So -3, -2. When we put those together and we make an equation, we're going to start with y equals, and then the y value, which is -2, minus 2/3 because my slope number is next, and then parentheses. Inside of the parentheses, there will be a +3 because that number is always the opposite of the number that you see. For problem number 3, I'm not going to give you a graph. Instead, I'm going to say write the equation of the line that is parallel to the equation that I gave you and goes through this new point. Now, if we want to be parallel, we need to have the same slope. So all I'm going to do is find the slope number in my equation, and I'm going to steal it and use it for my new equation that I'm about to write. My point is given to me in the instructions. They're telling me use the point 4, 1, and my slope is not given to me, but I'm just going to steal and use the same slope. Now I'm going to make my equation. So y equals my y plus 1/2, and then parentheses x, and then I'm going to put -4 because that number is always the opposite of the number that we started with. Let's try that one more time. Write the equation of the line that is parallel to the given line and passes through this point. Again, in order to write any equations, we need a point and we need a slope. They already gave me the point in the instructions. I can figure out the slope by finding the slope of the line that they gave me and stealing it and using it for my new equation. The slope of this line is -5 because that's the number right outside the parentheses. I can also put that over 1 to make it look like a fraction. Now I'm going to have y equals my starting y, which is 5, and then minus my slope number, which is 5/1, parentheses x, and then my x number is -7. So in the equation, it's going to be the opposite, and it's going to be +7. Okay, we've talked about parallel lines. We just steal and use the same slope to make lines parallel. Let's also talk about perpendicular lines. Now, perpendicular lines are going to intersect. That means they're going to cross each other. But specifically, they're going to intersect at a 90-degree angle. So lines that look like this are not perpendicular. But lines that look like this are perpendicular because they make a 90-degree angle. Now, these slopes are not the same. Instead, perpendicular lines have what are called opposite reciprocal slopes, which is a super fancy way of saying change the sign and flip the fraction. For example, if one of your lines has a slope that's a +1/2, the opposite reciprocal will be a -2/1. Change the sign and then flip the fraction. The symbol for perpendicular lines looks like an upside down T. Let's look at a graphical example of perpendicular lines. In this graph, we can find the slopes of each of these lines. This first slope is down 2 over 1, and the second slope is up 1 over 2. When I say first slope, I mean the slope of this pink line. And when I say second slope, I mean the slope of this blue line. Now what you'll notice is these two slopes are opposite reciprocals. We can figure out that they're flipped from each other and one's positive and one's negative. So that means that these lines are perpendicular. If we look at an equation like this one, we can tell if lines are perpendicular by looking at the slopes. This slope is positive 1/2 and this slope is negative 2. Now you might be thinking, Mrs. Vasta, how are those flipped from each other? The answer is the invisible number that's underneath this 2 is really a 1. 1 is positive, 1's negative, 1, and then the 1 over 2 flips and becomes a 2 over 1. These slopes are opposite reciprocals for each other. Now, one of the things I might ask you to do is graph a line that is perpendicular to a line that I give you. For example, this line right here has a slope, if I find the nice points, of up 2 over 1. In order to graph the perpendicular line, I'm going to need to figure out the opposite reciprocal. So I'm going to flip that fraction over and I'm going to change the sign to a negative. That means that for my new line, instead of going up 2 over 1 and copying the same slope, I need to go down 1 over 2. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. This new line that I drew is perpendicular to the original line. And if you look at this angle right here, the angle is a 90-degree angle. It's exactly 90 degrees. In order to write the equation of that line that we drew, we're going to need the key features. So we're going to need a starting point, and we're going to need a slope. Now, we already figured out the slope. The opposite reciprocal was negative 1 over 2. So we're going to use that slope for our line. The starting point is the point that I gave you to draw through. So negative 3 comma negative 2. And then we can put those together to make an equation. Y equals negative 2 minus 1/2, because the slope goes next, parentheses x, and then plus 3, because the x is always the opposite of the number you started with. Let's try that one more time. If I want to make a line that's perpendicular to this one, the first thing I'm going to do is figure out the slope of this one. Now this slope is down 2, right 1. Sorry, right 3. That means that the opposite reciprocal slope, the slope that I need to use, is the flipped, so 3 over 2, and opposite sign, so leave it positive. For my new line that I'm going to draw, that means that instead of going down, I'm going to be going up 3, right 2. So if I go up 3, right 2, that's right here. Up 3, right 2. And then I could also go backwards and draw my nice straight line. Now, if I ask you to write the equation of the line that you drew, you're going to need a starting point and you're going to need a slope. Your starting point is going to be the point that I marked for you on the graph. So negative 3 comma negative 2. And we already figured out that our slope should be positive 3 over 2 because that was the opposite reciprocal of the slope that was already there. Then I'm going to write my equation. Y equals my y, which is negative 2, plus 3 over 2, and then parentheses x, and inside of the parentheses is going to be a plus 3 because that number should always be the opposite of the number that you started with. Now, just like with parallel lines, sometimes I'm going to ask you to write the equation of a perpendicular line, but I'm not going to give you a graph. Instead, we need to read these instructions. We want to be perpendicular to this line and go through this point. Again, we're going to need a point and we're going to need a slope. I already told you what point to use in the instructions, 4, 1. The slope, though, we need to go look at this slope that's already here. Now, for a perpendicular line, we're not going to steal and use the same slope. Instead, we're going to figure out the opposite reciprocal, which would mean 2 over 1, so flip that fraction, and then also make it negative. My equation would be y equals my starting y, which was 1, minus 2 over 1, and then parentheses x, and then my starting x, which is minus 4. Remember, that number is always the opposite of the one that you started with. Again, I didn't use the same slope here. I used the opposite reciprocal because I wanted my lines to be perpendicular. Let's try that one more time. If I ask you to write the equation of the line that is perpendicular to this one and goes through this new starting point, anytime you need to write the equation, you're going to need a point and you're going to need a slope. The point is the one I already gave you, -7, 5. And the slope is going to be the opposite reciprocal of the line that we already have. Now this slope doesn't look like a fraction, but there's really an invisible 1 here. So the opposite reciprocal would be 1 over 5, and we would make it positive because it needs to be the opposite sign. Then we're going to put that information together in an equation. So y equals my starting y, which is 5, plus 1 over 5, and then parentheses x, and then my minus 7 would become a plus 7 because it's always the opposite. All right, let's just do a quick summary of what you need to know. The big idea here is that if I ever ask you to make lines that are parallel, that means that you need to have the same slope. If I ever ask you about lines that are perpendicular, that means that your slopes need to be opposite reciprocals. But there are going to be times when the lines are neither. They're not the same slopes, they're not opposite reciprocals. So let's look at this list of lines and let's find their slopes and see if we can find some lines that are parallel, perpendicular, or neither. For line A, the 2/3 is the slope. For line B, the -3 over 2 is the slope. Line C is -2/3, and line D is -3 over 2. If I ask you for some lines that are parallel, I'm looking for lines that have the same exact slope. The fractions need to be exactly the same. So in this case, B and D are both the same slope. I would say B is parallel to D because they have the same slope. If I say which lines are perpendicular, I'm looking for lines where the fractions are flipped and one's positive and one's negative. So an example would be like A, which is perpendicular to B. The fractions are flipped, one's positive, one's negative. We could also say that A was perpendicular to D. Their fractions are also flipped and one's positive and one's negative. And we would say because they have opposite reciprocal slopes. And if I say which of these lines are neither of the above, an example would be like B and C. The fractions are flipped, but they're both negative, so they're not opposite reciprocals, and they're not the same. So in other words, we would say they're not the same slope, and they're not opposite reciprocals. All right, that's it for today's video. Thank you all so much for watching. Please start your practice.